Hello, this is my ECE 376 term project, Morse code decoder. So a little bit about Morse code. It was the first major form of electronic communication. Human operators on a separate end of a wire would send each other messages where the letters were encoded by a series of pulses. Now, while this was eventually automated, telegraphy was the first major application of electricity, and the people who worked on telegraphs were the first electrical engineers. So how does our PIC decode Morse code? Well, first, our PIC needs to measure the lengths of pulses, several of them, determine what is a long pulse, a short pulse, and the end of a letter, and then we're going to translate a collection of pulses into characters and display them on an LCD. So how does the interrupt service routine work? Well, RB1 is connected to RC2 through hardware, so we can use a capture compare interrupt with a button on the PIC board. The capture interrupts measure a pulse to 1 millisecond accuracy, and then it stores the information in an array. The array is size 4, and it stores all the pulses that we need to decode a Morse code letter. During this time, timer 0 is actually locked. The capture interrupt actually unlocks timer 0, but resets the clock every rising falling edge. So that means if RB0 isn't pressed for 3/4 of a second, it knows it can start decoding what you just pressed, and it starts the main loop and then locks itself. If we didn't lock it, it would just ask the main routine to decode a letter every 0.75 seconds, which is not what we want to do. So what happens in the main loop? So the main loop actually does nothing until the interrupt service routine triggers it, and we take our information we got from our capture compare interrupt, and we do bitwise operations on a binary number, which is just 0 at the beginning. The first 2 bits are how many pulses total were there. We need that because you need to distinguish between there being a blank space and a short pulse. And the last 4 bits will compare the pulse to a threshold, and if it is larger than the threshold, it will assign 1 to it, meaning the pulse is long. So, how do we display the information we put on this binary number as a letter in the PIC LCD? So, at the beginning of the program, we have an array, and each element of the array corresponds to the letter of an alphabet. In the main loop, we're going to use a for loop, and we are going to compare the binary number to everything in the array, and if we have a match, we display it on the LCD. And afterwards, all we have to do is reset all the pulse measurement information, and we are ready to record our next letter. So, in conclusion, Morse code was the earliest standard of communication over a wire, and the demand for telegraphs made electricity a practical industry instead of scientific research. The PIC decodes Morse code by comparing pulse lengths to a defined threshold, and then uses a reference table to display what the user beeped in. Now, instead of what we've been doing for most of the semester, where the main loop kind of does most of the stuff and the interrupts just do stuff with timing, this system actually has the interrupts control the system as the whole, while the main loop just computes what letter you put in.